Okay, so after many attempts at fixing this stinking thing, so just to give you a brief history, when I first got it, I was told the e-stop button was bad because every time you turn the control on, it would say e-stop error. And so I messed with it and messed with it and messed with it. Come to find out, back here, see if I can just move this out of the way real quick. So back in here you see those fiber lines right here. So these are fiber optic lines that are coming from this computer to the PLC in the back. This one was hidden and broken, so it shouldn't look like that. There was a whole nother piece that was right here that clicks in, so you can see the little thing there. Turns out I replaced, there was another one laying in the control where they'd run an extra, and it's right there. So I just swapped it here, and on the back side here, so you can see the other end of the broken one, and right there on the end right here, that's the one that was extra. So that got the PLC running, and that was fantastic. But then the turret was out of alignment, so basically this tool was like pointing this way. So took this cover off, took this cover back here off. There were sensors back here that needed to be realigned, and this was on the spline wrong, so pulls it, you know, there's a cover and a nut, take that off, the turret pulls out, and I rotated it until I found the right spline, stuck it back on. Now that's right, so we're good there. So I was thinking I was good, and then you try to turn the spindle on, it didn't work. So the M3, which would be this direction, and M4 is this direction, only M4 worked. So what I found is this was a lathe project that somebody had apparently done at some point, and all of their G code was written with M4, which is again backwards to what it should be. That should be the reverse. So M3, my understanding, should turn this way, M4 should turn this way. But what was weird is when you issued an M4, it turned this way. So I figured out that if I took my G code and I did it like an M3, but then went through and replaced all the M3s with M4s, I could try and run parts. So that got me a little closer. Then I got online and started on the Centroid forum. Now I will say this, I've been on forums before asking for help, and 6 months, a year later, you're still asking that question and nobody's even bothered to ask. There is a guy on there, I can't remember his handle now, but he within 6 hours answered all kinds of questions, helped me kind of understand how this thing works. So if you go here, you can see the inputs and outputs and all that. This is basically a graphical representation of your PLC board. So if I go in and I turn this from auto to manual, you'll see that 6 right there lighting up. So you can see that it's telling it auto or manual mode. That's all through the PLC. Now I can go in here, and this is forward or an M3, and if I hit this and do that, hit start, you can see that turns on and my spindle's running. So either way, once he kind of helped me understand a lot of this stuff and how, I guess, the logic of this thing worked, which actually more simple than I would have thought. Then it was just a matter of tracing some wiring down and figuring some stuff out. So I figured out that if you look, well, actually, let me show you on this thing. So this is the wiring diagram that I got with the machine. And honestly, I'm not good at reading wiring diagrams, but this is your PLC, and this is the VFD. So VFD is a variable frequency drive. You can it changes a bunch of characteristics about motors and how they run. A lot of CNC machines have them. But you see, this is a Hitachi SJ100. But when I went back here and looked at this, this is not a Hitachi. This is something else. Westinghouse, Tico, something like that. I forget. But I found the manual in here, which I've moved it some. Oh, here it is. Yeah, this is a Tico Westinghouse Flexmaster 100. So somebody has changed the original VFD from what it was over there to this one. So the more I messed with it, what I did is I just copied this section, the PLC section of my schematic over here, just to make it a little easier to work with. And then I went through the manual in the VFD. So here's the part that sort of matters to this situation. What it would do is it would only turn in the reverse, well, basically forward direction, but they'd wired it to where it would reverse. This was the setting they had it at. So you have to go into the VFD and you have to set function 10 to 1 and function 3 to 0, and this is the wiring diagram essentially. So if you look, you've got one switch for forward and one switch for reverse, and that's it. So you switch the one for forward on and forward runs, and you unswitch that one and switch the one for reverse. So you've got a switch right here. When you short between reverse and common, it tells the VFD to run the motor in reverse. Switch from forward to common, tells it to run forward. Problem is, that is not how Centroid works. So right here, you can see some of my notes. You've got a relay 14 and relay 15. So when you turn the spindle on forward, what it does is this is spindle enable. So this relay turns on, and so you've got 14 out and 14 common that short together like a switch, and that tells it to run the spindle. And then when you say I want to go in reverse, this stays on, and this one switches from normally connected to normally open. So when I hit reverse, this little bar here rotates up to that contact, and then where these two, the 15 normally connected and 15 common were connected, now not connected is no longer normally connected. That's confusing. What it does is it goes from this one to this one. So I've got to find a situation where one switch, so when I short from here to here, that's my start, and when I short from here to here as well. So I can't just do one or the other, I have to do both for reverse. Well, there's this setup. So I ended up going into the VFD and changing function 3 to a 0001, which gives me this. So you've got an on-off switch here, an on-off switch here, and essentially when you turn this on, the spindle turns on. So this would be your output 14 in the schematic here, and this is your output 15. So when I tell it to start in forward, it shorts this wire to this wire. When I tell it to go in reverse, this stays on, and this one also turns on. So this is your forward and reverse switch. So what that looks like, let me grab my, oh shoot, oh, back here, this is my VFD, and you can see the terminals down here. So you see reverse here, common here, and forward's hiding behind these wires. So you've got the white wire, the black wire, the blue wire. That's your common, forward, and reverse. And these wires were going here. I have no idea what that does. I don't know why it was there. I ended up going directly to the PLC. These are literally just signal wires. I don't know why it would need something like super heavy duty or anything like that to run. So I ran out of here and into here directly into the PLC. So you see the blue wire, the black wire, and the white wire. So that fixed my spindle and got it where it was working. So at that point I can go into MDI. I can do M3 S200. So that's spindle on, turning this way, 200 RPM. If I hit start, oh, there we go. So now you can see it running. So now I can do M4 S200, enter, hit start, and you see it slow down and go the other direction. So that worked. So then I ran a program last night. This is the program here. Let me get out of this, go to edit. So real simple program, but you can see it's doing M3, if I can find it, there it is, M3 spindle 656, and you can go through here, and what it's supposed to do, if I can get back out of this, you can go to graph here. Okay, so this is essentially what it's doing. It's doing a facing cut here, and then it's doing small step overs this way. And there's a 33 Jacobs taper and a 0.625 shaft here, and then it comes in and does a cutoff right there. So when I would run that, the tool would sort of come over and start working, and it would kind of go like this, and it would come back, and then it would slam this way. Just run as hard as it could down this way and error out. So I would get this weird error. Looked in the manual, and basically it said you might have a ground issue and some other stuff, but I went ahead and posted a video and some other stuff on the CNC forum, and somebody told me to go in to let's see, setup, config, 137 I think is the password, parameters, and option 34 was set to -8,000. That's something to do with the, well, here it is, spindle encoder counts per revolution. What he said is because somebody had sort of rigged this up to run backwards, maybe that needed to be, instead of a -8,000, a +8,000. So I changed that, and I'm going to get out of there, and that's on auto. Turn that, hit start, start again, and oh, what did I just do? Oh, anyway, it did this right a minute ago. I was trying to turn the coolant off. I don't have coolant down in here yet, so I don't want that pump to run dry. But it ran. It went in. It did a bunch of stuff. It cut exactly like what you expected to see on this screen. So I think I'm functional. So I'm going to fill up the coolant reservoir, get that ready to go, and probably redo my program to not turn on the coolant, just to do some test cuts. And eventually I'm going to pull this bar out here and make that part. But I just wanted to update you guys. It looks like this thing is finally working. This feels like it's been a year since I got this thing and started working on it, but it's only been a little while. But all the issues apparently are solved. Hopefully I'll run a part, and when I do that, you'll get to see it. So have a good day.